Okay, ladies and gentlemen, we have a huge crowd, so please hold your questions until the end. So today we have eight mind-bogglingly stunning new findings and developments in the field of medical research, which I want to share with you. The first one is the dynamics of low LDL-C in the presence and absence of steroids, of statins. So the point is that doctors want you to get your LDL-C down because then the cardiovascular disease does not rise as fast as it was. However, when the LDL-C goes down, it turns out that the tendency to develop type 2 diabetes goes up. And a study was reputedly done in Italy. I'll have a word to say about that in a minute, which showed that this happened in the presence or the absence of statins. So if you're doing the best you can with the statins, it still turns out that lowering the LDL-C is problematic in this one regard. The author of the study was Gaetano Santulli, which could well be in Italian, but the truth is when you look at the fine print, he was actually working at Albert Einstein Department of Medicine in New York. Okay, now on to the second topic. This was work done at UCLA, and the idea here was that they prepared a new version of CAR T cells called CAR NK T cells. I'm not going to go over the difference, but the point is you start out with stem cells and you convert them to this CAR T cell, which has an appetite for going after tumor cells with a particular protein inside of them. And they tested this out in mice on pancreatic cancer. This is an apparent pancreas there with the cancer nodules in it. The advantage of this particular well-worked out cell was that it would go after the tumor, but not only hit the outside like most therapies do, but go into the pancreas where the tumor resides in bulk. And the tumor normally has a way of sort of shutting down things on the inside. It doesn't work with the CAR T cells. In addition, the appetite to go after the tumor cells is such that when there's metastasis and far from the original tumor, these cells still chase after it. So it's a sort of a mind-bogglingly more appropriate way of getting the cancer. As I said, it was effective in mice, and it's probably a long way from human use. Our third topic is back to the cholesterol business. There is a new drug called enlicitide. What is the value of enlicitide? Well, it turns out that when you have high lipids, you take certain drugs in a certain order. So the one after the statin is called a PCSK9 inhibitor, and that can work sometimes when the other does not. The PCSK9 inhibitor also may not work. So they did a study, which was reported in JAMA, using this new drug, enlicitide, and enlicitide over the course of the study, which was done in 17 different countries on 300 patients, it lowered their lipids by approximately 58%, which is phenomenal. And those in the control group, which were just taking the PCSK9 inhibitor, their lipids went up by 2.6% in the same time period, which was a year. Okay, topic 4, we go to the Broad Institute. Now you see this is broad, but the name didn't come from the fact that the building was broad. It came from the fact that there was a very well-known businessman named David Broad who donated the money for this institute. And the idea is that this is a conjoint effort between Harvard and MIT to solve the most difficult problems at the forefront of medicine. It's sort of on the far end of MIT from the Harvard point of view. It's nowhere near Harvard, but it's almost contiguous with MIT. It's the Broad Institute, and they have a senior fellow there named David Liu, Liu, and he works incredibly hard. There are things that you could do in life that are pleasant and exciting and wonderful, but he does this research in lieu of that. What he has a whole group, and they're working on this, and they want to see if they can come up with a therapy which would work on a whole variety of metabolic diseases which could respond to this one therapy rather than doing a particular drug for each therapy, because the kind of thing he's looking for is present in about 300 different types. So they said, well, what about the process? What is it about these particular diseases that is common and is the cause? And they were aware that the diseases are characterized by what is called a nonsense mutation, which is where the process for developing the protein from the DNA signal stops at a certain point and doesn't go on. So the protein you get from that is nonsense. It doesn't have its own function. So maybe there's something about this process that we could generalize so that we do one drug for all of them, or most of them, or some of them, and don't spend tens or hundreds of millions of dollars getting them through the FDA each time, and then catering to only a smaller group of customers. So they came up with an idea that they could modify the tRNA, which is the last step in changing nucleic acid into protein. They could come up with their own tRNA, which would overcome this nonsense mutation barrier. And the name for the process they developed was PERT, P-E-R-T. And that's a complicated name, but it's basically prime edit read through a protein terminator codons. PERT is a little bit easier to deal with mentally, but it also raises the possibility that all these other scientists are doing work that is impertinent. I didn't hear clapping or laughing, but I have to keep working at it. So this was published in Nature. His postdoctoral fellows wandered through thousands and tens of thousands of different models of tRNA to find the one that could perform this function best. And they came up with one, and they tested it out on Better's disease, Tay-Sachs disease, and Niemann-Pick disease, and applied this to approximately 30% of the genetic diseases of this type in addition. And they have come up with some favorable results. So the thing is to wait to see how far this can go, because it's very ingenious, and you don't get to be a master at the Broad Institute without having a lot of mental capacity to share the problem. Okay, now we go on to a different kind of question, which is what is the value of having a career in medicine when you consider the stress levels the uh, the personnel are exposed to. And it turns out that when they study this, approximately a tenth of them are found to be seeking out psychological results with providers of their own or taking drugs for it. And when COVID hit, the stress level went up that much higher, and it was up to 17%, as noted in the Annals of Internal Medicine. So if you're going to be a healthcare provider in our era, you better be ready for some stress. Topic number 8, the FDA, under the leadership of appointees chosen by our dear president, have decided to remove the black box warning sign on certain hormonal therapies intended for menopausal women who need hormonal support. Their idea is that this therapy is beneficial and more so than any of the other diseases that are treated by medicines. Uh, so why complicate the matter by showing the black box? Now, the black box was applied to these drugs, the hormonal therapy, in 2003 after a considerable trial showed there was some reason to have a warning sign there. But they said, no, we don't need that. And by the way, you shouldn't be you shouldn't be getting any treatments like vaccines because they don't have benefit. So it's sort of a crazy world we're living in. Okay, now, what about the value of our medical and scientific literature? It turns out that when an individual looked at this, it turns out that approximately 40% of research papers in one particular field, which was just chosen as a sample, were clearly fraudulent in nature. They took pictures from one and pretended they were part of their study and other things like this. And this problem with uh, fraudulence in the publications is only going up in the presence of AI, which allows you to do these copycat functions even more straightforward. Uh, the journals have sort of strange response to this. A lot of times they don't want to know, so they don't check it out too much. And a lot of times they find out, but they don't withdraw them. Um, so that's sort of a mind-boggler to somebody who's been taught that science is about seeking truth and presenting the value of truth to mankind. Uh, Now, our final topic is a work which is done at NYU Langone in New York. And this is a transplant achievement. As you know, there are tens of thousands of people waiting for the appropriate transplant to be available to them so they can get the organ they need to rise above their disease. And this group decided that there might be some way to use animal tissues instead. Animal organs are more available. So they chose to take a kidney from a pig and transplant it into somebody who needed a kidney transplant. The patient on the receiving end was a person, not a mouse, but he was brain dead. So he went along with the study. And he was in organ failure. When they put in this pig kidney, it functioned. So his renal function was restored to normal. Over a 61-day trial, the organ was rejected twice. They had treated the organ prior to using it to make it as resistant as possible to rejection, but it rejected twice, and they were able to quell the rejection in vivo so that the kidney went back into normal function. And that was the main achievement that the authors and the commentators were excited about, because if you could keep on quashing the rejection, it's like having a functioning organ ongoing. And there's a lot more pigs than there are donors. In fact, what you do is you just stop eating bacon for breakfast for a couple months, and all of a sudden you've got a pig that's all ready to go. Better world we're heading towards, and thank you very much.